What you're seeing right now is the display of the NI PXI system that is used as a signal generator for generating the clock input for the ADC. As you can see, the frequency of the clock is 1 GHz and the power level is 5 dBm, which results in an output voltage peak-to-peak differential of 1.125 across 50 ohms. So we are zooming on to the NI measurement and instrumentation system, where we can see that we are running the VSG-VM-UC application to enable the signal generator. And the signal generator is running, which shows because otherwise it wouldn't show stop over there. We are showing the display of the NI PXI system. As you can see, the clock is coming out from the RF out through the green cable. That green cable and NI again, and we are displaying the NI National Instruments PXI system. The pencil is denoting the green cable, which is acting as a clock out. This is getting into the clock input of the ADC, which is then coupled through a transformer on the board. Also, you can see that there is the motherboard, which is actually the power board, and on top of the motherboard is sitting the daughter card, which has the chip, which is wire bonded onto the PCB. The signal input is coming through the other green cable where the pencil is right now. That cable is going to Regiland signal generator, which has a maximum output frequency of 10 MHz only, as you can see there. And we are applying a 1 MHz clock input, the signal input with a peak-to-peak swing of 1.2 volts differential. The quality of this signal generator is not that great, but unfortunately we only have this in our lab here. Again, we are zooming on to the both the motherboard and the daughter board. As you can see, the logic analyzer cables are connected for the data output, and now we are zooming on to the logic analyzer, which captures the data using the pods, and this is showing that the data is getting into A2 and A3, and CK0 is the clock out from the ADC, that is from the chip, and we are using the falling edge of that clock, which is coming out of the ADC for capturing the data. Now it shows the captured data waveform, the bits. These are just the raw bits coming out of the ADC. These bits are then taken into MATLAB for generating the sine wave and taking the FFT. So to take it into MATLAB, we just use it in the listing mode, and then we go for file and export the data. And we save it as a text file as shown above, listing space 108.txt. This is then processed in MATLAB, and this shows the MATLAB code which captures the data. Has shown that it is reading the file listing -108.txt and then processing it, and then finally it plots the output of the overall ADC output, and you can see that the sine wave is there. Since the output of the ADC is decimated by a factor of 32, and you can see that the sine wave it has some glitches because some of the wire bonds have come out, because this is a 2.5-year-old board, and because of that the sine wave is not that clean, and you can see periodic jumps. This is because a couple of wire bonds have come out. It is staying outside, it is not hermetically sealed. We are showing the console panel of the signal generator, logic analyzer, sorry. The logic analyzer actually has MATLAB in it, so we could process everything right there. Again, we are zooming on to the signal generator. Now the complete setup is being shown. The complete setup with the PXI system on the right, the logic analyzer on the left, the signal generator in the middle, and the board also right there with connected to this logic analyzer.